Page 36, first question. Describe how the values change. Okay, how does each one change? Well, what's this one doing?
It's squared and times 10.
Squared times 10. This one is just doubling 2 to that power. So they're both increasing. You just have to describe what you see there. Both are increasing. So describe that in your own words. Predict which expression will have a greater value. This is just a prediction. So you're either going to pick 10x squared or 2 to the x for each one. You're just predicting which one's going to be bigger. C, you're actually finding it. Find the value. So 8 squared times 10, 640. 10 squared times 10, it's 1,000. 12 squared times 10, 1440. 2 to that power, 2 to the 8th, though it's not the next one here. You got, it's not 2 to the 5th, 256. 1024, it's skipped, yes. 4096. Make an observation about how the values of the two expressions change as x becomes greater. So right away, the quadratic is clear to be bigger until we get to this point, and then the exponential catches it. Question number 2, which function is a quadratic? Which one is exponential? Hopefully, we're beyond this. The quadratic is the one that's got the x squared. The exponential is one that has the variable as an exponent. Which one will eventually become larger? The exponential will always catch up as long as this number is bigger than 1. Those answers are always the same there, guys. Create a table. Fine. That shows 3, 2 to the x, and compared to the quadratic. I'll just do 1, 2, 3, 4, 5. So 2 to the first power is 2 times 3, 6. 2 to the second power is 4 times 3, 12 times 2 times 2 times 2 times 2. Hopefully you see that at that point. Quadratic, 1 squared times 3 plus 2 times 1. 3 plus 2 is 5. 2 squared is 4 times 3 is 12 plus 2 times 2. 12 plus 4, 16. And then you should get 33, 56, 85. So this one does not take long. By the 5th power, the exponential has already overtaken the quadratic. Question number 4. Use the patterns in the table, explain why eventually the values of the exponential will overtake 10x squared. Well, we can see it does. Can we not? Nope, it doesn't yet. Well, the exponential will always catch up. Anybody have a number where it does? I didn't go that far either. Obviously after 5. But you can tell this one's growing a lot more than this one. Question number 5. It's not asking us when, so we won't have to worry about it. What is the area of the shape in step 10? Yeah, so if you look at this, again, I'm looking for squared, squares. Okay, so in step 3, it's 4 by 4 minus 2. So it's 1 more than the step. Step 2 is a 3 by 3 minus 2, 1 more than the step. So to show 1 more than the step, it's n plus 1. The step plus 1, you're squaring that, and then you're subtracting the two little corners. So what is the area of the shape in step 10? 10 plus 1 is 11. 11 squared. Anybody got 11 squared memorized? 121 minus 2. 119. What is the area? We already have that one figured out. We wrote the equation. Explain we did that when we wrote the equation as well. Question number 6, write the expression in dollars after 1 year. So if it loses 3/5 of its value, it holds on to 2/5 or 40% of its value. So 240 times 0.4 or times 2/5. 240 times 0.4. $96. Oh, it says write the expression. We don't even have to figure it out. All right, 240 times 2/5. 240 times 2/5 squared. 240 times 2/5 to the third, or 0.4 if you want a decimal. When will the bike be worth less than $1? So there's 1 year. 2, 3, 4, 5, 6. 6 years. It'll be less than $1. Will it ever be at 0? Why not?
Just never does.
Because it's like that. We'll keep getting closer and closer to 0, but we'll never be exactly, because you're not taking it times 0. Question 7. All right, it wants us to graph this inequality on there as well. Bless you. So if x is 0, y could be 1200, so I'm going to put a little dot up at 1200. If x is 0, y is 1200. If y is 0, x is 1200. To put another dot at 1200. Connect those two, dotted line. And everything below that. B, use the graphs to find at least 2 possible combinations that the farmer could plant. So I'm looking for 2 dots that are inside of both of those shaded region.
500, 100, 100, 200.
All right, say that again.
500, 100.
500 and 100.
And 100 and 200.
100 and 200. Again, just any points inside of where they both are shaded. The combination of 400 and 700 meets one constraint, but not the other. Which one does it meet? So 400, 700, which one does it meet?
W plus C less than 1,200.
Yeah, it meets this one. Again, how can I tell? Well, it's in that shaded region, but it's not in the other. So it is not less than the $250,000. That's the one it doesn't meet. All right, go ahead and do the warm-up today.